Hey everyone, this is episode 2 of Learning Rust with Sean and Kate. Today we're going to be going over chapter 2 of the Rust programming language book, and that talks through kind of basic programming features that are pretty common to every language and how they look in Rust. So, yeah. All right. So Sean was kind enough to create a bunch of REPLs with some examples, so we can talk through each of these features, and then we're going to see how many we get through. But there were 3 challenges at the end of this chapter, so we're going to go through each one of those.
And one of them is a really awesome Christmas Carol challenge. So I figure the driver will be coding and the navigator will be like singing suggestions or guidance or whatever. I don't know.
Sounds great. All right. So, Sean, you want to talk about this first example?
Yeah, absolutely. So in this chapter, we basically learned about a lot of the language constructs provided by Rust. The first construct that the chapter discussed was variables. And we talked a little bit about this in the previous video, but one of the really interesting things about Rust variables is that they're immutable by default. So you can see on like line 3 that we're declaring a variable number of days. And we have the keyword mute to say that it's mutable. We also have this explicitly typed as an unsigned integer of 8 bits. And so once we have that number of days, basically our objective here is we're just trying to say how many seconds are involved in how many seconds does it take to go through that number of days. And so to be able to produce that, I've created a function called print seconds. And it takes a certain number of days and it prints out the number of seconds to the screen. Couple of things that I have in this example is if you look inside the function, I actually use shadowing to change the number of days variable from an unsigned int of 8 bits to an unsigned int of 32 bits. And I actually had to look up something in the Rust documentation, specifically that into function, which seems like the way that you kind of cast between 2 different data types there.
Interesting. So what happens when you didn't use that into method?
I think I got a type error. Can you take it off
Okay.
and see what happens?
Yeah. Ah, doesn't like that.
Uh-oh, we have a connection error.
Oh no.
REPL!
We were doing so well with all the audio and video, only to be
Yes,
thwarted by a REPL.
thwarted by the REPL. So we are taking off that. We're saving and we're running. And oh, cool. So the compiler actually tells you what needs to be done there. We got a type error.
Mm-hmm.
And
We're not declaring number of days as mutable on line 10, so I would have expected that to work.
let me think about that.
Yeah.
So you're saying like up here, something like that?
Um, right.
Yeah, I have no idea if that's even valid syntax. Let's see.
Right. So the book talks about like the kind of scenarios where you would use mutable variables over shadowing.
Hmm.
And so one of the pros of using shadowing is that you can use the same variable name but
Right,
assign it different types. So that's
right.
why in this scenario I was curious why that would be an error. But maybe it's something about how parameters are defined. I'm not totally sure how that works.
Yeah. So I think we did an example before where we went from a string from
Hmm.
standard in, and then we cast that into like an int or something like that.
Yeah.
Um, and I'm kind of thinking maybe we have to do this because it's like particular types of integers, like 8-bit versus 32.
Hmm.
I don't know.
All right.
But one thing you might be kind of wondering is like why even have line 11? So like if we comment that out, um, down on like 15 here, we still have number of days defined. So do you think this will work?
Hmm. Well, by your tone, I'm guessing not, but um,
So I just hit run. If you look at towards the bottom of your console, you'll see there's an error where it's like can't multiply U32 and U8.
oh, interesting.
Yeah. So
I
I
guess.
was kind of hoping that there'd be some sort of automatic conversion here since it's like the same kind of type but different precisions
Right.
basically. Um, but it's a little strict.
Interesting.
So that's why I had to have this shadowing thing. And then one other thing that I thought was interesting was this const, which like seeing both let and const really kind of reiterates this looks a lot like JavaScript to me.
Right. Except
um,
const is more strict here.
so yeah, it's compile time
Yeah.
super strict. Okay.
But
And this is kind of like something I've seen in like Java before. This kind of underscore thing, which is kind of neat. So it's like in human readable terms, we're used to like commas or whatever.
mhm,
And so we can basically just break it out because if we had like 50 digits there or something, that might be kind of confusing.
right.
So I think I restored everything and now it's running. And so like if I take off this mutable thing, I should get an error.
Hmm. Cannot assign twice to an immutable variable.
Cool. So I think that's pretty much everything about variables, right?
Yeah. Data types. Okay. So, do you want to tell us what you have going on here? A lot of stuff
Yeah.
happening.
Yeah. So this is super, super busy. Basically, I wanted to express the size and the values that could be stored in each of these different data types.
Hmm.
I think all of our tabs are probably disconnected, but are you able to hit run?
Yep. Can't believe REPL let us down like this.
Oh boy. It's because I don't have a pro plan, probably. Um, yeah. So you can see in the console basically the different types of data types,
Hmm.
the size of memory they consume. So like assigned integer um, 8 is 1 byte because
Hmm.
8 bits are in 1 byte. And then we can see like what it can store. So that's one negative 128 to 127, including 0.
Hmm.
And then it just gets bigger until iSize, and that's basically like whatever the architecture of your processor is. Like so pretty much nobody is like a 32-bit processor anymore, except like maybe my old Raspberry Pi or something like that, but that would be 32 on like that Raspberry Pi thing. Yeah, so the unsigned integers, you can see that they don't have any negative signs, which is why they're unsigned. They start at 0 and they go up to a higher value. And so it's just kind of like the whole range is shifted basically.
Hmm.
And the floats, like I think some of those values are kind of long and scary, and I don't fully understand what that's expressing. But floats are a little bit different because when you're 64-bit, you actually have more precision, and I don't think it just strictly increases the range per se.
Hmm.
Um, so so I guess that's the like the minimum and maximum values with just kind of low precision. And then like we have all the same kind of familiar math operations
Yep.
that we saw before. And I don't have one on here, but I know. Oh, we're connected again. Thank you, REPL tech support. So, okay, so we saw we could do something like this, right?
Yep. Right. We were playing around with that last week, and the book didn't actually explicitly talk about that, but looks like it works, which is nice.
We're hackers. We found something the book didn't cover. Okay, so I would expect that we could do that like twice,
Don't
right?
forget your semicolons.
Oh, thank you. Ah, okay. No, this is a good point. Do you know why this is failing?
I don't see any error.
So I'm seeing an error and it says empty tuple does not implement standard format display. So I think what this gets to is the difference between an expression and a statement.
Mm-hmm.
So I think this is a statement because it's doing assignment, and that makes sense.
Right. So we would have to do that above the print statement and then include it.
Like we could,
Right.
I think, do that, but it would be the same value each time.
Yeah, so that's one thing the book talked about, which is the difference between statements and expressions, and um, how.
Let's not. We'll talk about it in a later tab, though.
Okay, okay, all right.
Yeah,
Don't want to spoil
we'll come back to that in I think the functions tab.
it.
So
Okay.
stay tuned. Um, so I like the Booleans there. Does that look strange to you, or does that look pretty standard, Kate?
Looks standard to me.
Yeah.
Yep.
I mean, I guess the one thing that might be different is like scripting languages have kind of like they have true and false, but they also have like truthy and
Right.
falsy. So it's kind of like the if statement needs like a Boolean here, and it can't. It needs to be a Boolean or
Yep. It has to
something that
be. It has to evaluate to a boolean. So you can't do the JavaScripty thing of like if array.length, then do this.
right. Yeah. Yeah. And then characters are pretty much like pretty standard. The only thing that's kind of different here that is it's kind of from C. Like there's a difference between a string and a character, and that affects if you use single or double quotes.
Oh, I didn't
So
know about that.
yeah. So I don't even know. Is it okay? So something like that would be like a string, and we're using double quotes.
Interesting.
Um, but for a single character, we have to use single quotes.
Okay. So if you put another emoji in there, that would be a string.
If I put another emoji in there right now, I think it's going to break. Let's see. Let's put in.
How much pride can it handle?
Okay. Double rainbow. Let's see what happens.
Okay.
It says character literal may only contain one code point.
All right. Well,
And then
there you
it
go.
has a overlapping double rainbow with an error line underneath.
So sad.
Yeah.
All right. Cool.
Oh, but
Let's
one
continue.
one thing that I thought was kind of weird here. So you restored it. you might notice that I have like two spaces here.
Mm, yeah.
So like I guess a Unicode emoji might actually like it's not the same width as like a character. It's like double width. So like if I just had one space there, can you go ahead and run that? Try again, maybe. Oh man, it's not syncing. But
Yeah.
so the rainbow would basically have no space before pride.
Gotcha.
Yeah.
Interesting.
So what's your favorite data type?
That's hard. I mean, usize is pretty cool.
Uh-huh.
Um, those unsigned ints.
Uh-huh.
Um, Booleans are always a classic.
It's a classic. Yeah.
What about you?
Um yeah, maybe that use size is kind of cool because it's like if we were to code something and use like U64,
Hmm.
um, I
We might,
guess like if you try to compile on like an embedded system, it just may not work, I guess.
right? So you take advantage of the system you're running on, whatever.
Maybe in like 100 years, there's going to be a 128-bit system,
Right.
and then
So
we automatically can use that.
future
Like,
proof.
yeah.
That's great.
So I felt like the chapter kind of cheated us a little bit on collections
Yeah.
because it was like we got this thing tuples and we got this thing arrays, but no one ever really uses arrays. We use this other thing vectors, and it just mentions it.
Yeah. Yeah.
And
I
then it's like
was curious about
yeah,
that too. It really didn't say at all what they were, except that they come from the standard library.
right.
Um, and they can change in size.
But yeah, so like the I mean the big difference between vectors and arrays then is basically like fixed capacity, I
Right.
think.
Yep.
Um, which then basically makes this behave pretty much just like an array in C. So
Hmm.
you can either like do this kind of thing that on line 14 where you declare and initialize all at once, and then this has got four things, so it allocates four slots.
Yep.
Um, or you could I have no idea what the syntax for this, but I presume there's some way where you do like some sort of like what is it? Is it like new
Yeah.
array? And probably you pass in like a length or something like that.
Right.
But yeah, I'm kind of spitballing syntax wise. It'd be
Something
something like
like
that
that.
probably.
Yeah. Cool. So this first example here, you where you're running this divulge personal details function, you declare a tuple called details.
Hmm.
Um, a tuple. Did we define what a tuple was? Did we actually say that yet?
No, you're
Okay.
about to do it right now.
All right. So it's a way to kind of group a variety of types into like one compound type. So here we have a unsigned 8-bit integer, 32-bit, and then two 32-bit floats. Um,
Mhm.
and then we're passing that to the divulge personal details function. And in that function, we're doing some destructuring, which is familiar to us JavaScript devs. But that's one thing I was curious about. In the book, they talk about destructuring using pattern matching. And I didn't quite understand what that meant, destructuring using pattern matching. Do you know what that might refer to?
I actually don't. I don't remember that in the book either. I must have zoned out. I don't know. I mean, so I kind of am used to thinking of tuples as basically they care about order,
Uh
like
huh.
kind of like index position,
Right.
similar to arrays.
Okay.
Um, so I don't know if you're saying pattern matching, maybe if we only use like a data type once each, it kind of tries to match as best it can.
Yeah. I don't know. Something to. I think pattern matching will definitely come up again. So
Yeah.
we'll see. All right. You want to run this? Or I'll run it.
Up, divulged all my details. uh, so, Kate, do you even know what the Ninja Turtles are?
I do. I've never watched them, but I know
Okay.
generally
Like,
that.
do you know the colors associated with the different turtles?
I think there's like blue, orange, purple, green, maybe? No?
Blue. Oh, now let me hold on. Let me think about it. So Leonardo, I think is blue. Donatello is purple. Raphael is red,
I
and
know
I think Michelangelo is orange.
I know Raphael's
Maybe
the bad boy, right?
he's like the angry one. Like, so he's kind of the angry, violent one. Michelangelo is like the chill party guy. Donatello's the big nerd. Like he'd be the programmer. And
Nice.
then Leonardo is like the leader guy. um, yeah, I'm an '80s kid. I don't know. That's
Yeah, I missed that one. I'm sorry.
so you can create the REPL next time and do references you're familiar with.
Sure. Sounds good. Okay. So let's go on to functions
Mhm.
here. Um, so function bodies can contain either expressions, um, which evaluate and return some results, or statements which just perform an action without returning anything. So function bodies are made up of those two kind of things. Um, and the what I thought was interesting was the implicit returns that functions in Rust have. So if you don't end a statement with a semicolon, it becomes an expression. In this example, this function will automatically return the last expression.
Mhm.
But here, we shouldn't see anything. So let's try that. We'll add we'll run that first add function.
Uh-oh. Oh, there.
That's fine. So we got some warnings about an unused expression and function. But that checks out, I think. So let's try uncommenting this, running the second line.
Yeah, and that looks right. So we kind of had an example like this in the chapter where it mentioned that empty tuple is kind of like the default return if we don't have like an
Mm-hmm.
expression at the end of the block.
Right. So if we wanted to fix this, could we add a return statement here?
Mm. Oh yeah, we need to add a return type.
Yes, a return type. So a return type is notated like this in Rust. Little arrow,
The skinny arrow.
skinny arrow. All right, and that works this time. Yeah.
So so which of those two alternatives do you like better?
I mean, the last one is more explicit. It's
Yeah.
very clear what's happening. Coming from JavaScript, I would the first example here on line 8 might be a little confusing.
Yeah.
Um,
I agree.
yeah.
um yeah. So like some languages really buy into this kind of implicit return thing.
Mm-hmm.
Like I've done a tiny little bit of Ruby, and Ruby, it's kind of like everything is like an expression almost. Like every statement returns something, so there's like
Huh.
no meaningful difference between an expression and a statement. And
Interesting.
so like any block, like the return value of the block is like the last statement basically. So like that kind of feels Ruby-ish, but it's like because you have to leave that semicolon off, then it looks like, I don't know. To me, I'm used to thinking like you left the semicolon off, you made a mistake, I guess.
Right. Yeah, exactly. Or just not even registering the semicolon at all.
Right.
Um, so, what else about functions? They talk about snake case is the standard for functions.
Yeah.
You can call any function that's defined, no matter where it is in scope. Right, that was one thing. I think
Oh,
that's basically.
I mean, maybe one. I don't think we have it in this example, but can we maybe if we go back to maybe collections, there might be something to talk about. So if you look at the divulge personal details, you'll see that there's like an ampersand in front of the string.
Uh huh.
Um, and I had to basically insert that because if I just had name string, I was having like a type error because I guess a string is like a complex type and you have to pass by reference for
Hmm.
that. I don't
Interesting.
know. It seems like going forward as we kind of develop more complex code, we'll have to probably fiddle with things and get some feedback from the compiler and stuff for references versus pass by value.
Cool. All right.
Um,
So, last one we have here is control flow.
mhm.
Do you want to talk through this one?
Yes, absolutely. Um, so so we learned quite a few different types of control flows. We have the kind of if statements, and I just have a couple of examples that kind of build on some of the concepts we talked about. So like on line 6 here,
Yeah.
I have what kind of is like a it looks like a ternary expression to me. Um, so in some languages you have a special syntax with like a question mark and then if true return this colon,
Right.
if false return that. Um, we have maybe Rust has that. I suspect it doesn't, and I suspect that the they basically have this kind of implicit return
Mm-hmm.
if else thing as kind of the equivalent shorthand syntax,
Right.
um, which I think it reads pretty good.
Yeah, I liked it. It's very clear.
Yeah,
It's clearer than a ternary for sure.
yeah. Um, let's see what else is in here, and then I mean, other than that, we have different types of loops. In our last video, we basically went through kind of the basic loop,
Mm-hmm.
which was just the unconditional loop for our guessing game.
Yep.
And since it was unconditional, like we had to implement if statements to like break or continue and stuff like that inside the loop.
Mm-hmm.
Um, and similarly, we have that in here.
Mm-hmm.
And then so we have to check inside the block for the loop, and we have to increment in our particular case here.
Yep.
And you can kind of see as we go to like the conditional while loop and then we go to the for, it's like we get a little bit more syntactic sugar
Mm-hmm.
each time.
For sure.
Um,
Can you talk about
like
this uh, dot iter method?
yeah. So the chapter didn't really talk about it, but like this whole syntax, it looks very familiar with like kind of a Python generator iterator type thing or JavaScript too. So I think like when we call that iter function, we get
Mm-hmm.
a iterable back,
Okay.
and then the for in loop consumes that.
Gotcha. What do you think an iterable is or looks like? I guess. What do you think it's actually doing?
Yeah. Yeah. Like, so JavaScript ES7
Hmm.
added, maybe I think it's ES7 added generators and iterators, but it's like because it's so hard to polyfill, I think most front end devs don't really use them.
Yeah, I've never used that.
Yeah, so I've done just a little bit. So like an iterator is kind of like it's like a function with like a yield statement on the inside, and you call like a dot next, and it
Uh-huh.
advances to like the next yield statement.
Yep, I've seen that before.
Um, and so then when you have a structure like that, you can then basically have like special for loops
Hmm.
that advance to the next yield statement and then take the return value and execute on the for loop for that. Um, so the cool thing there is like it makes our syntax super super simple.
Yeah, it's
So
really
it's just
nice.
yeah, and so like in Python, generators and iterators are considered like super Pythonic, and if you do anything else, you're wrong, and they make fun of you. And so it seems like Rust has some of that similar dynamics. So like down on like line 36, they're doing basically what like a normal C or JavaScript developer would do like a for loop for, like
Hmm.
um for I equals zero, I
Yep.
less than blah blah blah, I plus
Right.
plus type structure.
Yeah.
But here we're using a range, and so that special dot one dot two basically is creating a range from one to three.
Hmm.
So the four is excluded, and then that dot rev basically reverses the elements in place.
Yep. Yeah, I think this syntax is cleaner than
Mhm.
JavaScript. For
So
loops.
like if we were to add a new Ninja Turtle, let's see what would happen there and which loops would be able to handle that. So like this is your example, Kate, to create a new Ninja Turtle and name him or her.
Oh man.
Ooh, you're on theme.
Yeah. Right. Um, okay. I think our session is a little messed up here, but I
Okay.
think VS Code, I guess, is the way to go.
It could, yeah, it could be. We're learning as we go.
Yeah.
Sorry, internet.
So I'm not able to run this, but can you?
Yeah. So I guess tell me what you think would
Yeah,
happen.
in each of these different loops, right?
Yeah.
Okay, so this first loop, we have we're incrementing the loop based on this turtle count variable. So that didn't change. So I would expect we wouldn't print out our fifth turtle.
Hmm.
The second while loop, same thing, unless we
Hmm.
changed our turtle count variable. But this last one, we are actually going off the length of the array, so I would expect it to work.
Cool. Yeah. And you're right.
Wow.
Yay. So now that we're going to move on to the I guess the pair programming part.
Yeah.
So we probably I bet I'm going to have to resend the sessions. Well,
Yeah.
let's see. Let's see. Maybe they haven't timed out. Like,
Maybe I can refresh. That seems to work.
okay.
Cool.
All right. Can you run it?
Let's see. Great.
So I guess let's go ahead and pair program this thing. Do you have any conceptual questions about converting between Celsius and Fahrenheit?
I don't think so.
You don't think so?
I think I got it. Okay, so what do we want to name this first? Let's do Fahrenheit to Celsius first. So um, let's see. 32c, something like that. So if we take in a parameter f, maybe, let's see, what kind of data type do we want? It could be a float.
Mm-hmm.
So maybe maybe one of these.
Yeah. The book mentioned 32-bit floats are the fastest.
Yeah. Cool. So we've got our function, and I'm just going to copy this and reverse it. Cool. Okay.
Looks good so far.
All right. We know we want to return a float. So maybe we could do that here.
Mm-hmm.
So I'm thinking we should declare some sort of variable to store our return value.
Can I propose a radical idea?
Okay.
What if we don't?
Sure. We could implicitly return something as well.
Yeah.
Let's try this.
Is it going to do it?
All right, let's try it out. So let's say 99 degrees Fahrenheit is all right, and then to see all right, try that. All right, so got some errors.
Okay.
Yeah.
That's a good one.
So we need to handle both floats and integers, don't we? So if we did this, interesting.
So you could change 32 to 32.0.
I could. Okay.
Mm-hmm.
Checks out. So how could we handle both? Or should we kind of leave that for now?
Do you mind if I try something really quick? I'm really curious. So sometimes a language has a special syntax for expressing the type here, and usually it's like you put like an F.
Yes, I've seen this before too. I think you have to do F32 though. Yeah.
Let's see.
Are you like casting there, kind of? I know you said there was no casting, but it kind of feels like that's what you're doing because 99 is an integer.
Yeah, it's saying like, even though I don't have a period here, imagine, if you will, a dot zero, I guess.
Okay.
Yeah, it's like, I think that's probably fine then. Like, to expect people to be able to have to do that.
Okay.
And if we were in like VS Code, we'd have like IntelliSense saying float 32.
Right. Okay, I'm satisfied.
So probably we could have the same thing down here, I would think too.
Mm,
If
cool.
okay.
All right.
Um,
Now the next one. Let's here's our formula. Let's invert that. So we would want
go
to
for it.
c times 1.8 plus 32.
Hmm.
All right, and then let's try. All right, let's try that.
Mm.
Okay. And it wants us to add a return type. So we'll give it F32 again.
Oh, you're calling F to C twice.
Oh, good call.
Cool. Yeah,
All right.
I think that's good. Um, so let's try one other thing. So
Okay.
what if we had an array of temperatures like let's say we wanted to create a printout with like a table where on one side we had, one 0 to 100,
Uh huh.
and the other side would be the opposite type of temperature.
Okay. Do we have time to do that and go through our other examples?
Maybe not. Okay.
No, I'm. We could focus on this one, and maybe
Uh,
if we don't have to do the 12 days of Christmas.
yeah, yeah. The 12 days of Christmas is probably pretty crazy.
Yeah.
So, why don't we do that in here and then
Okay.
skip the 12 days of Christmas?
All right. I like it.
Okay.
Okay.
Or we could break off and do it as homework and compare
Sure.
next week.
Yeah, that works too.
Okay. Can I possibly drive for
Yeah.
the
Go for it.
okay. Okay. So I'm thinking here, let's have let me take a look at here at my collections. Okay. So here's our Ninja Turtles. So instead of Ninja Turtles, we want temperatures. Now,
What about using a range?
boom! I threw you a softball. um, yeah, cool. So if I use a range, I don't need this. So let's see. So it was like 4F in 0 dot dot 101,
Mm-hmm.
something like that.
Yep.
Okay. So now we are going to template that in. F and I bet this range is integers and we're going to get an error. But let's see what happens. help remove these parentheses. So I have a syntax error.
Mm-hmm.
Okay, let me look at it.
Unnecessary. It's a warning, I think. So I
Oh,
think
it's
you're
a warning.
okay about
Okay.
that.
But then
But
then we got
it's
the error we expected.
yeah.
Okay, cool. So these are optional.
Mm-hmm.
So let me just confirm the warning goes away.
Yep.
Okay. So I wonder if I can do this.
Yeah. I was curious about that too.
Or I wonder if that's even possible.
Yeah, I don't know. Let's try it.
I'm not feeling good about this. I think, yeah, that looks totally not possible. So how about we shadow?
I like it.
Uh, F, right? And let's see what. So we were discussing if we need to do that dot into before, right?
Right, right. Yeah, this would be good candidate.
Okay. So I think from, okay. Let F. Okay, so syntax issue. All right, so I want to convert from a integer to a float. And a float does not have convert from, so that into doesn't work. So we need to learn how to cast then.
Okay. I'm curious, would something like this work, adding decimals?
Let's give it a shot.
Oh, well, let's comment that for a second. No. Iterators. Oh, interesting. I wonder if I could do something like this and make it iterable. Ah. Nope.
So I vaguely recall that when you have a float range, you need to somehow express the step value.
Ah.
Um,
That would make sense because it's like
yeah,
what is the next, what is the incremented value? Um,
I see something. It's probably not the most efficient means, but so what I'm thinking is whatever the new
mm-hmm,
is.
mm-hmm.
No, I'm not feeling good about that. Wait, is okay. Okay, no, I actually found an example of as.
Okay.
Um, so let's delete that. So F as F32.
Mm-hmm. Yeah, I found something like that too.
Okay, I think that was it, right?
Nice.
um, Okay, cool. So now we know how to
Yeah.
primitive casting. All right, not
Primitive
too bad.
cast. Cool.
So the flip side here would just be pretty much the exact same.
And then line
Good.
14. C as.
All right. Thank you.
Mhm. Nice.
I'm looking at the results here, though. Oh,
Yeah,
I
there's.
see. Okay, right, because of that. Okay, cool. So I think that's probably done. I mean, I guess like since these are so short, I almost want to make these one-liners.
Mm,
How do you feel
fancy.
about that?
I feel good about it.
Okay. Yeah. Yeah. It looks nice and mathematical.
It does. Beautiful.
Um, cool. So shall we move on to Fibonacci?
Let's do it. All right.
So do you know the history of Fibonacci at all, Kate?
I don't know the history.
So like there's a crazy Wikipedia article, but I seem to recall that it's something like a medieval monk
Mm-hmm.
was wondering he was like studying how quickly rabbits reproduce or something like that. And I think he thought this Fibonacci number described that, but of course it doesn't.
Yeah.
But it's a neat number anyway.
Cool. Yeah, I didn't know the rabbit story. I'll have to check
I
that
feel
out.
like I think I messed up at least two or three parts of that story. Like he may not have been a monk. He might have just been an Italian guy.
Just a
And I
guy.
just like, maybe he's a monk.
Yeah. So Fibonacci sequence, pretty common interview question, but
Yeah.
basically a mathematical sequence where each item in the sequence is the uh, result of the two previous numbers added together. So
Hmm.
that would give us something like 0, 1, 0 plus 1 is 1, 1 plus 1 is 2, 3, 5, etc. So um, this problem, we need to take in an index, basically, of some number in this sequence. So maybe the third Fibonacci number, which would return 1, the fourth would return 2, etc. So I think we can do the same thing as we did for uh, the other problem. We can maybe create a Fibonacci function. Fib, if you want to be cool.
It's pretty
Like that.
cool. Go for it.
Do you want to?
All right, so we're totally disconnected. So you're driving this one, by the
Oh, I
way.
am. Okay.
Yeah.
All right. So we Sean and I did talk about this briefly that we're going to go for the maybe kind of slow recursive solution first. Um,
We can talk a little bit about computer sciencey stuff after if you're interested.
yeah, some dynamic programming.
Oh, woo, woo. Wait, you know stuff. You've been learning.
I maybe know a little. Yeah. Um, so we're gonna take in a number n. Um, we don't need a float, and we don't need any negative integers. So maybe a U32 will do. What do you think about that?
Sure.
All right. So the first thing, our base case. What do you think our base case would be, Sean?
I think our base case would be 0 or 1,
And why?
because they're kind of the the two things that are explicitly described, and everything else builds on those.
Right. So if we hit the case where n equals 0, we know that we can just return n because n will be 0, and the same with 1.
Mm-hmm.
So if n is equal to 1 or less than 1, right? So then we want to... So here, I guess we would want to return n. Do you think we could implicitly return it? I'm not sure yet, but maybe...
Yeah, I'm thinking about it here. So, like, I mean, because the values. Okay, yeah. So you're saying if I get what you're saying. Yeah,
Yeah.
I think you implicitly return.
Yeah, we could try that out.
Yeah, it should, because it's just a general thing for a block of code. So I think it should.
Right.
Should work.
The question is, though, will it evaluate the next line if we do that? Or will it break out of the function and return it? I'm not sure.
Yeah, that. I think. I think it will. Yeah, as long as the other thing is in a different arm.
In a different arm. All right. So you implying you want an else?
Yeah, totally.
All right. Okay. So in our else, we can also do an implicit return here, and we want to add the previous two values. So we can call fib with n minus 1, and then we want to add that to fib n minus 2.
Mm-hmm.
All right. So let's test this.
You've got a typo.
Oh. So let's print out this result. We can do it here. So the third Fibonacci number is, and then we'll call fib with 3. And we should expect that it gives us 1. All right, we need a return type. And the reason why it's saying that the types are mismatched, I believe is because the thing we're returning here is an unsigned 32-bit integer, and then the thing that we told it to return is nothing, right?
Yeah.
So those types don't match.
Right.
So let's try this.
Why don't you use a range to give us like the first 5 Fibonacci's?
Sure. So first 5, and then
I think that's the first 6. 0, 1, 2, 3, 4, 5.
Right. Sorry.
And I think the parentheses are optional.
Oh yeah. Sorry. Okay. How's that look?
I think that looks good. But you have third Fibonacci?
Let's just do this.
Yeah.
Right. Okay, can't do that. Okay. It's getting stuck.
Uh-oh.
There we go.
Okay. So that looks good to me.
Yeah. All right.
So I guess let's look at 12 Days of Christmas so we know what our homework is.
Sure. All right. So we need to print the lyrics to 12 Days of Christmas taking advantage of repetition.
Uh-huh.
So this is needs to be our result in the console.
That's a tedious song.
Yeah, it really is.
Like so whenever I've been in a group singing that song, I'm just like, dang, this takes forever. Like,
Wish we had some loops here.
well, it's yeah, everyone gets exhausted, and then until you get to the five golden rings. I feel like a comedian talks about this, but
Yeah, that does sound familiar.
yeah.
Sure.
Mm, mm, mm. So I'm just trying to think about it. I feel like it's almost like a range and kind of, and then but it gets longer each time.
Hmm.
So it's like a nest, maybe even like a nested loop, and then in the innermost loop we're
Yeah.
appending the additional day to the
Yeah.
to the
No
string or
spoilers. No spoilers.
I don't know. Yeah. Okay.
But yeah, that sounds like the right path.
Hmm.
Cool.
It'll be fun.
Yeah. All right. So next week is, let's see.
I think it's ownership is the next chapter, and we
Ownership.
need to decide if we're covering one or two chapters.
Okay. Yeah, this chapter was particularly long, so maybe we can do two, but let's see.
Yeah. Yeah, let's do 4 and 5.
All right. Cool.
Cool. You're pro Kate.
All
Great to
right.
work on this stuff with you.
Yeah, this is great.
Yeah.
Awesome. All right. Well, thanks for watching, everyone.
Have a wonderful week. Bye.